This tire is not rubber. It is an intelligent organ that changes its anatomy 50 times per second. Imagine a 2-ton armored object that reaches its first 100 faster than a top-tier supercar, completely ignoring inertia and the laws of friction. In front of you is an engineering paradox known as the Deliverer. He has less than 5 minutes left. Ahead lies a closed residential sector, reinforced with armored gates and automatic access control systems. Behind him is the reputation of a structure that does not forgive delays, not even by a second. To be on time, the driver does not need a miracle. He needs a machine capable of ignoring the laws of the city and the physics of the road surface. This is not just a vehicle. This is the Deliverer, a tool created for a single purpose, to guarantee the transport of cargo from point A to point B amid urban chaos. The body of the object is made from a multi-layer composite. On the outside is a deep radar-absorbing coating that makes the car virtually invisible to standard police radars. Beneath this stealth shell lies a combination of Kevlar weave and ceramic plates capable of withstanding direct fire from small arms. The power unit is an electric drive with an abnormally high torque output. It has enough power to accelerate a 2-ton armored vehicle to 100 kilometers per hour in less than 3 seconds. At this level of acceleration, the car does not simply move, it literally bites into space, leaving scorched traces on the asphalt. This scenario and the Deliverer itself are not just products of imagination. They are inspired by the cult novel Snow Crash by Neal Stephenson. Written in the early 90s, it became a true technical manifesto that predicted the development of transportation decades ahead. Today, we will examine where in this vision, fiction ends and real engineering begins. The key advantage of the object is hidden in an area no larger than a human palm: the contact patch. The Deliverer's tires are not a passive consumable, but an active computational node known as smart tires. The technology is based on adaptive morphology. Instead of standard pressure adjustment, the system uses electroactive polymers, or EAP. Under the influence of ultra-precise electrical impulses, the polymer structure of the tread changes at the molecular level. Depending on road conditions, the surface instantly switches between 3 states. In slick mode, the system achieves peak adhesion levels. Engineers call this the Gecko Effect. On a microscopic scale, the tread mimics the reptile's anatomy by utilizing van der Waals forces. Millions of polymer setae create a molecular bond with the road surface, allowing the 2-ton vehicle to literally stick to the asphalt during high-speed cornering, effectively defying centrifugal force. Aquaplaning prevention. When moisture is detected, the structure opens up, forming channels for instant water evacuation. Grip mode. On loose ground, the polymer forms aggressive sipes that work like claws. Today, these ideas are taking shape in real laboratories. We see shape memory alloys such as nitinol being used in NASA rover wheel designs. These structures can withstand extreme deformation and always return to their original form. Concepts like Hankook iFlex and Kumho MaxPlo are already testing the physical limits of airless systems. The Deliverer project simply combines these developments with the power of neural networks, turning the wheel into a fully fledged part of an intelligent chassis. In a critical situation, the driver activates the augmented reality system. The windshield becomes a continuous monitor. Navigation projects the optimal trajectory directly onto the landscape, highlighting hidden obstacles and weak points in fences. The car leaves the road, cutting the corner through private property. Sensors detect slip on wet grass, and the chassis adapts in mere milliseconds. A jump, a hard landing, the suspension absorbs the impact energy and instantly redistributes it into the next burst of acceleration. The Deliverer does not follow the route, it creates the route itself. The car freezes at the target. The timer stops 3 seconds before the critical mark. The silence is broken only by the soft hum of the cooling systems. Today, technologies like adaptive tires and through vision systems are already stepping out of the labs of NASA and defense agencies. The Deliverer project is not fantasy, but the logical endpoint of current engineering trends. The only question is how quickly these technologies will become standard on our roads.